Hello future data scientist, my name is Pratham Chandratre and welcome to the episode 2 of Mastering Linear Regression. And today we are gonna start with geometric intuition of linear regression. Please make sure guys you like this video so that YouTube recommends it to more and more learners who are actually learning and struggling in the field of machine learning. In the last video, we have actually seen the dataset which we have taken, and same dataset we will actually take in today's video guys in order to understand the geometric intuition of linear regression. See here we have actually taken number of study hours as our independent feature and exam score based on the number of study hours as our dependent feature. So here our input feature is number of study hours of a student, and based on the number of study hours he is basically doing, based on that we will basically predict the exam score of a student. Like suppose student is basically studying for 8 hours, then his exam score would be 90. Now based on this we will basically plot these data points on a scatter plot. Basically we will plot this on x and y axis. Now let's see here, basically I have basically drawn the geometric intuition for you so that our time span of our video should be less and our video should not be lengthy. So I have already prepared a notes for you. So basically on the x-axis we have basically plot a number of study hours which is our input feature, and on our y-axis we have basically plot an exam score which is our dependent feature. Now guys, imagine you have actually studied for 5 hours and you got 60 marks, and your friend suppose studied for 7 hours and he got 80 marks. Now the big question is, if a new student studies for 9 hours, then how we can actually predict their score? Let's go beyond just talking guys and actually see the geometry behind simple linear regression. See, simple linear regression is about finding a straight line that connects our inputs. See, this is actually the straight line which we called as the best fit line in linear regression. So simple linear regression is all about finding this best fit line that actually connects our input, which is number of study hours, to our output, which is basically exam score. But how to exactly draw that line? That's where geometric intuition comes into a picture in simple linear regression guys. Now imagine we plot all the students on the graph. Now here basically you are seeing the data points in brown color. These are basically data points, these are basically data points, these are basically data points. This data point indicates that based on the number of study hours, how much exam score he has basically got. Now based on this, see, based on number of study hours, how much exam score the student has basically got. This data point are indicating this thing guys. Now if we plot all students on the graph, like on an x-axis we have basically plot a number of study hours, and on the y-axis we have basically plot the exam score. So every point on the graph is one student guys. Now the challenge is, can we draw a single line that captures the trend of our pattern guys, that finds the trend, that captures our trend? And that's not just a random line guys, it's what we called as best fit line in simple linear regression. But the big question is how to know actually which line is best. Well, the line should be as close to all those scattered points. We derive that line based on the distance between our original output feature and our predicted feature guys, our actual value and our predicted value. Now you are getting confused that which is actual value and which is predicted value. See, this is basically our data point guys on which we are finding out the value. Okay, so based on this data point, let's suppose this data point is x data point. This is the actual value which our data has. This yi is basically the actual value, and this yi hat which is on the best fit line, it is basically the predicted value by our linear regression model. So this is the actual value and this is the predicted value, and this vertical line, this vertical white line, it is basically the distance between our actual value which is yi and the distance between the predicted value which is yi hat by our machine learning model. So this is basically the data point which we are calculating the value. This data point's actual value is basically yi, and this data point's predicted value is basically yi hat, and this is basically the distance, or we can say the difference between the actual data point and our predicted data point. So our main aim of a simple linear regression is that guys, we have to find this best fit line, this yellow color line which is our best fit line in our example, in such a way that our error should be as minimum as possible. So the secret actually lies in minimizing this error base guys. So our goal is basically to choose a line in which that actually makes the error as small as possible. Like for an example, These all are our actual data points. The brown data points which you see are our actual data points. This yi, this is basically our actual data point, this is basically our actual data point, this is basically our actual data point, and this all are our actual data point. And our main aim is that, and we have to basically draw the best fit line in such a way that the distance from the actual data point and our predicted data point should be as minimum as possible. Now this is basically our predicted data point, this is basically our predicted data point. The data points on our best fit line are basically our predicted data point in our example. So here we have drawn the best fit line in such a way that the distance between our yi, which is our actual data point, and yi hat, which is our predicted data point, should be as minimum as possible. So this is what we achieve with the help of best fit line in simple linear regression, and this is what our goal is to achieve, guys. Think of it like a balancing ruler on a messy pile of stones. The ruler is our regression line, guys, which is our best fit line, and the stones are our data points, the scattered data points. Okay, the ruler will naturally settle in a position where the imbalance, that is the error, is as minimum as possible. That's exactly what regression does, guys. It is basically used to find the balance. So that was all about the geometric intuition of linear regression, guys. So here I have noted down, guys, main aim of our geometric intuition of simple linear regression is that we have to basically minimize the error rate. We have to basically minimize the distance between our actual data point and our predicted data point. So what is here error? Error is basically the distance between our actual data point and our predicted data point. So we have to minimize the error, guys. So to wrap it entire video, geometric intuition of a simple linear regression is all about finding that one straight line, finding that one best fit line which keeps the error as small as possible. It's not magic, it's a geometry plus little math. So if this clicked for you, smash that like button and also share it with your friends, because trust me, once you understand the geometrical part, the mathematics part of regression suddenly becomes much more simpler. And in the next part, guys, we will study about the equation of the best fit line. So see you all in the next one.